One of the best uses of percent by mass is to convert that data into an empirical formula for the compound. This is typically what we get. So in my laboratory, I make some compound. I don't know what it is. I will package it up, a small sample, send it off to a laboratory, and that laboratory will send information back to me about percent by mass, saying, for example, there are 30% of the mass is carbon, 10% is oxygen, and so on. And we use that to convert into the empirical formula for that molecule. So to do this, we follow 3 steps always. And the first step I've listed here. So we're going to use the percent mass that we get back from the laboratory, and we assume that the sample size is 100 grams. That's why we use percent by mass. And if, for example, the data says that the percent mass of nitrogen is 35.3%, since I have 100 grams of my sample in my assumed sample, I know there's 35.3 grams of nitrogen in that sample. So if I have this sample, I'm saying it is 100 grams, and there's going to be a bunch of these things, and I'm saying in this case 35.3 grams equals nitrogen. Now the second step then is to convert grams to moles. So if I have 35.3 grams nitrogen, I'm going to cancel grams of nitrogen, and I want to go to moles of nitrogen. And in nitrogen, that is 14.01 grams for every 1 mole. So my units cancel. And in this particular case then, once I do that calculation, that turns out to tell me that I have 2.51963 moles of nitrogen in my sample. Now I've got to use significant figures. There are 3 here, so we're going to cut that right there, and that actually becomes 2.52, and we're going to have to be careful with significant digits here. And now I'm going to do that for every element that's in that compound, and I'm going to then, in my third step, write down the ratio of those moles. So if this compound had carbon, if it had hydrogen, and if it had nitrogen, I would have got percent by masses for each of those, and I would write down X, I would write down Y, and then in this case, because the nitrogen is 2.52, I would write down right there. And then the last step, or I guess this is the 4th step, if I want to count this way, I divide by the smallest number. Because what that does, it will convert one of those mole numbers into 1. So if I divide every one of them by 2.52, so 2.52, because that's the smallest, let's say the others were, I don't know, 6 and 7, I would at least have, so my X would be some number, my Y would be some number, and N now is 1. And I'm going to have some simple ratio of whole numbers there, or I might not. I might have something like C, after I did that, 1.5 H1N1. Now I've got to make simple whole numbers, and how do I do that? I now start multiplying. So in this case, I could multiply 2 times each of those, and I would get, this would become a 3, this would become a 2, and that would become a 2, and that would be simple whole numbers, and that would be known as my empirical formula. Let me work a problem now. The first one of the homework, I'll do that next.